a review of reference angles. We use reference angles because they let us find sine, cos, or tan of an angle greater than 90 degrees. For every angle over 90 degrees, there's a matching reference angle under 90 degrees that will give the same answer. Now here's a little overview of the reference angles. In the first quadrant, the reference angle is just the angle itself. Because if I've got an angle of, say, 45 degrees, I'm just going to do sine of 45 degrees if I want sine of 45 degrees. So in the first quadrant, the reference angle is itself. In the second quadrant, our angles will be between 90 degrees and 180 degrees. And the angle here is thus obtuse. The reference angle is, basically it's here. One way of looking at the reference angles that may help is that, actually I'll give you some terminology. This is the initial arm of our angle. Just here, our angle's starting there, that's our initial arm. And the arm of the angle that is anywhere else out here in the unit circle is our terminal arm. So this is the terminal arm here. And the reference angle, look, theta with a little r, reference angle, is between the terminal arm, sorry about my terrible writing here, I'll fix that, and the horizontal, or the x-axis. Reference angle between the terminal arm and the horizontal, the x-axis. Reference angle between the terminal arm and the horizontal, the x-axis. Now the reason this is the reference angle for that comes back to our unit circle, which is upside down, that if I've got an angle coming out to this point here, if this is my reference angle because this here is my angle, the reference angle going this way from the x-axis up to the terminal arm will give the same value of x along the x-axis and y on the y-axis as this whole angle here does. So using this angle gets the same answer for sine, cos, or tan as we would for this big obtuse angle. And so when I've got an obtuse angle, the reference angle lets me get sine, cos, or tan because it's the same. So if theta here is 145 degrees, then this is obviously 180, take away that 145, 35 degrees. And if you grab your calculator, sine of 145 compared to sine of 35, we get the same answer. So we can use the reference angle to get the answer for an obtuse angle. So in the first quadrant, the reference angle is just the angle. In the second quadrant, the reference angle is the supplementary angle, and it's 180 degrees minus the angle. So the reference angle is found by doing 180, take away that obtuse angle, and we're left with the reference angle. In the third quadrant, looking at this rule, the reference angle is between the terminal arm of the angle and the horizontal axis. Here's my reference angle, just in here, because the whole angle, theta, is all the way around there. But for this big angle, we get the same answer using this little reference angle, the same value of x or y. If we look at our unit circle, if my angle came around to here, let's say it's 250 degrees, its value of y is here, its value of x is here. That's the same answer we'd get if I just took this angle in here, from the x-axis down to there. So my reference angle is in here, and that is my whole angle, take away that 180. So the reference angle, oops, we'll pop this over here. The reference angle is the angle all the way around, take away 180, so the opposite of that. The reference angle in the fourth quadrant, get myself another unit circle. If I'm over here and my angle's all the way around at 350 degrees, that's going to be the same answer as if I had just that angle there, which is 10 degrees. Because remember, sine is the y value, cos is the x value. They're the same for 10 degrees as 350 degrees. So my reference angle for here, reference angle is 360 degrees minus the angle I had. Another way of looking at it is that you're looking for a right angled triangle. You've got a big obtuse angle that won't make a right angled triangle, so you take the acute angle on the other side, that makes a right angled triangle. Second quadrant, here's my right angled triangle. Third quadrant, here's my right angled triangle. The angle's all the way around there, but there's a right angled triangle that will get the same answer. Fourth quadrant, the angle's all the way around there, but here's this right angled triangle that gets the same answer. Now the types of questions, and the other thing of course that we must remember is that reference angles give the correct values for sine, cos and tan, or the correct magnitude, the correct number, but they don't necessarily give the correct sign, positive or negative. That's where we take our unit circle and remember all stations to central. A, all are positive. S, sine is positive. T, tan is positive. C, cos is positive. So there's all this information that we need to know. I'll pop that in here in a different colour. All, sine, tan, cos. It's just which one's positive. Now I know that's been a long explanation. I'm sorry, I'm pretty sick, so I'm probably repeating myself. Here's the questions that we might end up having to answer. Find the reference angle for these angles. Now this is just asking me for the reference angle. 30 degrees, First quadrant, the reference angle is just the same as the angle. 190 degrees. Third quadrant. The reference angle is the angle that you've been given. Take away 180, so just this bit here. Reference angle, 190 minus 180, 10 degrees. 280, fourth quadrant. 360 minus the angle itself. So you find the quadrant that you're in. It's a really good idea to look at your unit circle and work out the reference angle. Find the value of the following in terms of their reference angle. Now this is where all stations to central comes in, because you've got to work out, are we going to need the negative or the positive? Tan 190 degrees. Which quadrant? Third quadrant. You'll notice, by the way, I've just used these ones here. So I know the reference angle is 10 degrees because we just found the reference angle for 190. And the question is going to be, yeah, I'm going to do tan of 10 degrees and I'll get the same answer as tan of 190, but should it be positive or negative? Tan of 10 would obviously be positive because all are positive. Tan in this quadrant will work out positive. So tan 190 is exactly the same as tan 10. Use your calculator if you need to check. Tan 190, tan of 10, exactly the same, signs are the same. So I can find the answer for tan 190 by getting tan 10. Sine 190, however, it's still going to be 10 degrees, sine of 10 degrees, but around here when I'm looking at 190 degrees, only tan is positive. So sine 190 should be negative. It'll be the same answer as sine of 10, but I'd have to get sine 10 and make it negative. Negative sine 10. If we had a look, sine of 10 degrees, sine of 190 degrees, same number but negative. So you can check your answer and your understanding by using your calculator. Cos 280 degrees. Now I found the reference angle of 280, it's 80 degrees, so it's going to be cos 80 degrees. The only question is negative or positive. Check which quadrant. 280, we're in quadrant 4, and cos is positive in quadrant 4. It's also positive up here when I've got an acute angle. So cos 280 is exactly the same as cos 80. But tan 280, tan isn't positive in that fourth quadrant, so this will be negative tan 80 degrees to get the same answer as tan 280. Tan of 200 degrees, we are in this quadrant here, the third one. So this will be our reference angle is 200 minus 180. Tan of 20 degrees. In this quadrant, tan is positive, so we're okay to leave them exactly the same. But cos of 200 would be negative cos 200 degrees because cos is negative in that quadrant. Find the two possible values when sine theta equals a half. Well, inverse sine of a half. Now I know my exact values, come to think of it. When sine is a half, it's 30 degrees. I don't even need my calculator. But which other angle has the same answer as 30 degrees where it gets sine of the angle as a half? Exactly the same answer means it has to also be positive. It's not equals negative a half. Sine is positive in this quadrant, so 30 degrees matches which angle in here? 180 minus 30, it matches 150. So 30 degrees or 150 degrees will give me sine of the angle is a half. Sorry, it's getting a bit messy in here. The two possible values when cos of the angle is root 2 over 2. Now this is sneakily using our exact values again. Cos is root 2 over 2, 45 degrees. So, theta could equal 45 degrees, but where could cos of the angle also give me that? Cos of the angle has to be positive, which means we're going to be down here, which says 45 degrees back in there will give me the same answer. So 360 minus 45 says that theta could be 315 degrees. Sorry about my dodgy writing, people. I'm so tired and this has gone so long. We can check that. So, cos of 45, root 2 over 2. Cos of 315, root 2 over 2. They're the two possible answers. Little extension concept for you. If the light doesn't destroy it. What is the other value of theta that will give the same result for each of these? This video's gone for way too long. Have a look. See if you can manage to get the answers that I'm popping in here. That's a 40. That's 20. And if you can't work out how, catch up with me at some stage and I'll go through it, but this video is too long.